When installing 750 watts high-intensity discharge lens-covered Highbay fixtures, it's crucial to adhere to safety guidelines and the National Electrical Code, or NEC, recommendations. For 750 watts high-intensity discharge fixtures, the NEC recommends a mounting height of 20 to 26 feet, which is 6.1 to 7.9 meters from the lens of the fixture to the floor. This requirement addresses potential hazards associated with high-intensity discharge lighting, specifically ultraviolet radiation emissions. The specific requirement for mounting height can be found in the National Electrical Code 2023, Article 905.12a. This section states that high-intensity discharge fixtures shall be mounted high enough so that personnel are not exposed to excessive levels of ultraviolet radiation. High-intensity discharge fixtures emit ultraviolet radiation, which can be harmful to human skin and eyes. Prolonged or excessive exposure can lead to various health issues, including sunburn, premature aging, and an increased risk of skin cancer. The higher the mounting height, the less intense the ultraviolet radiation exposure will be at floor level. The recommended mounting height of 20 to 26 feet ensures that the ultraviolet radiation exposure is within safe limits for personnel working beneath the fixture. This provides a safe working environment while still providing adequate illumination for the manufacturing facility. Several factors influence the determination of the optimal mounting height. Firstly, consider the specific design of the fixture. Different high-intensity discharge fixtures may have varying ultraviolet radiation emission characteristics. It's crucial to consult the manufacturer's specifications for guidance on the recommended mounting height for a particular fixture model. Secondly, ambient light conditions play a role. If the manufacturing facility has high levels of natural or artificial light, the high-intensity discharge fixtures may not need to be mounted as high. However, if the facility has low ambient light, a higher mounting height may be necessary to ensure adequate illumination while minimizing ultraviolet radiation exposure. Thirdly, consider the layout of the manufacturing facility. Factors such as ceiling height, the presence of obstructions, and the location of workstations may affect the optimal mounting height. It is essential to assess the specific needs of the facility and adjust the mounting height accordingly. In addition to the NEC requirements, it is always recommended to consult with the fixture manufacturer's instructions and a qualified electrician for specific mounting height recommendations. A qualified electrician can assess the specific conditions of the manufacturing facility and ensure that the high-intensity discharge fixtures are installed safely and effectively. They can also provide guidance on other safety measures, such as the use of personal protective equipment. The NEC is not a set of installation instructions. It is a guide to safe installation practices. The NEC provides a minimum baseline for safety. Oftentimes, local codes are more stringent, so checking with the local authority having jurisdiction is critical. There are several factors that should be considered when installing high-intensity discharge fixtures. Firstly, ensure that the fixtures are properly grounded to prevent electrical shocks. Secondly, use appropriate wiring and connectors that are rated for the voltage and amperage of the fixtures. Thirdly, secure the fixtures firmly to the ceiling to prevent them from falling. Fourthly, provide adequate ventilation to prevent the fixtures from overheating. Fifthly, install guards or barriers to protect the fixtures from physical damage. By following these safety measures, you can minimize the risk of accidents and injuries. Regular maintenance is essential to ensure the continued safe and effective operation of high-intensity discharge fixtures. Inspect the fixtures regularly for signs of damage or wear. Replace any damaged components promptly. Clean the lenses regularly to maintain optimal light output. Check the wiring and connections for any loose or corroded connections. Test the grounding system to ensure that it is functioning properly. By performing regular maintenance, you can extend the life of the fixtures and prevent potential safety hazards. Remember, the actual mounting height may vary slightly depending on factors such as the specific fixture design and the ambient light conditions. Always consult with the fixture manufacturer's instructions and a qualified electrician for specific mounting height recommendations. A qualified electrician will have the expertise to assess the specific conditions of the manufacturing facility and ensure that the high-intensity discharge fixtures are installed safely and effectively. In summary, when installing 750 watts high-intensity discharge Highbay fixtures, adhere to the NEC recommended mounting height of 20 to 26 feet. Prioritize safety by minimizing ultraviolet radiation exposure and following all applicable codes and regulations. Consult with qualified professionals to ensure proper installation and maintenance. This will create a safe and well-lit manufacturing environment. It is imperative to always prioritize safety when working with electrical systems. High-intensity discharge lighting systems operate at high voltages and can pose significant hazards if not handled properly. Always disconnect power to the circuit before working on the fixtures. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools to prevent electrical shocks. Follow all applicable codes and regulations. If you are not comfortable working with electrical systems, hire a qualified electrician. The NEC, or National Electrical Code, serves as the cornerstone of electrical safety in the United States. It is a comprehensive set of standards and guidelines designed to protect people and property from electrical hazards. It covers a wide range of electrical installations, including wiring, equipment, and systems. It is updated every 3 years to reflect the latest technological advancements and safety practices. The NEC is adopted by most states and local jurisdictions, and it is enforced by electrical inspectors. Compliance with the NEC is essential to ensure the safe and reliable operation of electrical systems. The NEC is organized into chapters, articles, and sections. Chapter 1 covers general requirements. Chapters 2 through 7 cover specific types of installations. Chapter 8 covers communications systems. Chapter 9 contains tables and examples. The articles within each chapter provide detailed requirements for specific aspects of electrical installations. The sections within each article provide specific instructions and guidelines. The NEC uses a system of numbering to identify specific requirements. For example, Section 300.14 covers the requirements for the length of free conductors at outlets and switches. The NEC also includes definitions of key terms and concepts. These definitions are essential for understanding the requirements of the code. The NEC is a complex and comprehensive document. It is important to consult the NEC regularly to ensure that electrical installations comply with the latest requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other organizations. The NFPA also offers training courses and certifications on the NEC. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include local building codes, state electrical codes, and industry standards. It is important to be aware of all applicable codes and standards and to comply with them. High-intensity discharge lighting is a type of electrical gas discharge lamp which produces light by means of an electric arc between tungsten electrodes housed inside a translucent or transparent fused quartz or fused aluminum arc tube. This tube is filled with both a noble gas and often also suitable metallic salts. The noble gas enables the arc's initial strike. Once the arc is started, it heats and evaporates the metallic salts. These metallic vapors greatly increase the intensity of the light produced by the arc and reduce its power consumption. High-intensity discharge lamps are more efficient than incandescent and fluorescent lamps. They are more commonly used for high-intensity lighting of large areas, often outdoors, and require a ballast to regulate their current. High-intensity discharge lamps include mercury vapor, metal halide, ceramic metal halide, and high-pressure sodium lamps. The ballast limits the current. A ballast is a type of electrical transformer used to limit the amount of current to the lamp. Without a ballast, a lamp would draw too much current and burn out quickly. The ballast also provides the starting voltage needed to start the lamp. High-intensity discharge lamps require a warm-up period. It takes several minutes for the lamp to reach its full brightness. This is because the metallic salts need to heat up and evaporate. High-intensity discharge lamps are not dimmable. The light output is not linear and is not suitable for dimming applications. High-intensity discharge lamps are sensitive to voltage fluctuations. If the voltage fluctuates too much, the lamp may flicker or go out. High-intensity discharge lamps contain mercury. Mercury is a hazardous material and must be disposed of properly. Check with your local waste management company for instructions on how to dispose of high-intensity discharge lamps. High-intensity discharge lamps are a cost-effective way to light large areas. They are more efficient than incandescent and fluorescent lamps and have a long lifespan. However, they require a ballast and are not dimmable. They also contain mercury and must be disposed of properly. It is important to check with your local municipality and waste management company on how to handle these bulbs that contain mercury. The information is provided to the best of our ability and should be used as a guide. Always refer to the NEC and local codes.